And welcome to our lecture on P3. I expect this will be broken up into 2 or 3 videos. We'll see how long this takes us. So in P3 we're going to be talking about integer exponents and scientific notation. I honestly only expect we'll get to integer exponents today. Let's talk about integer exponents. Integers, if you recall, are whole numbers, positive or negative. So we're not going to be considering fractions in the exponent or irrational numbers like the square root of 2 or anything like that. We're just considering whole numbers, positive or negative. So this is just an introduction to exponential notation. It just tells you if you have a raised to the n power, where n is an integer, then that literally just means you line up n a's and you multiply them. So 3 to the 4th is 3 times 3 times 3 times 3, 4 3's, and that would be 81. Now, if you're going to look at 0 and negative powers, let's just look at some powers of 3 over here. We know 3 to the 4th is 81. I draw my 4 a little bit better there. We know 3 to the 3rd is 27. 3 to the 2 is 9. And I'm sure you're familiar, if you raise something to the first power, it just gives you the number back. But if you notice, getting from a power to the previous power is just a matter of dividing out the base. So you take 81 divided by 3, you get 27. Divide by 3, you get 9. Divide by 3, you get 3. And if you divide by 3 again, you get 3 to the 0, which is just 1. It's a very common error in my students to say, if you take something to the 0 power, it's 0. But it's not. It's going to be 1. And you can keep going. If you keep dividing by 3, divide again, you will get 1 over 3. Oh, by the way, before we really move on that much from the 0 exponents, I just want to point out here, any number raised to the 0 power is going to be 1. If you think about anything raised to the first power, you know, even 1037 or 5096, to the first power is just the number, and if you divide by the number to get to the 0th power, you're just going to get 1. 5096 divided by 5096 is just 1. And that's what this says. Any number to the 0 power is going to be 1. Any number to the 0 power is going to be 1 except 0. 0 is the only exception. 0 to the 0th power is undefined. Getting back to the negatives, a to the negative n is just going to be 1 over a to the n. You can already see here it's 1 over 3 to the 1, 3 to the negative 2. It's not coming through very brightly there. There we go. 1 over negative 2 would just be 1 over 9, because you divide by 3 again. If you divide by 3, it would be the same thing as multiplying times 1/3, or 1 over 3 squared. And similarly, 3 to the negative 3 would be 1 over 27, or 1 over 3 to the 3rd. And so on. Now I wanted to point out in the examples here that just as a negative exponent will flip the number to the denominator, a negative exponent on a number on the denominator, 7 to the negative 2, will just flip it back up to the numerator. So here, 7 to the negative 2 became 7 to the 2 on the top, and there's no need to write the bottom anymore, because once you move it off, it just becomes 1. And dividing by 1 has no effect. So that's how we get 98, because 2 times 7 squared, that's 2 times 49, is 98. Alright, moving on. The rest of the section is just dealing with laws of exponents. The laws of exponents, as shown here, tell you how, when you're doing operations with exponential expressions, numbers raised to exponents, how the exponents interact. This first law, law number 1, tells you if you have two exponential expressions with the same base. So you see I have 3 to the 2, 3 to the 5. In that case, you deal with the exponents by just adding them together. And that's fairly easy to see why. If you look at 3 squared times 3 to the 5th, 3 squared literally means, by the definition we just saw, 3 times 3. Put that in parentheses. And 3 to the 5th is just 5 threes. Times 3 times 3 times 3. These parentheses are basically meaningless because, as we saw in the last section, by the associative property of multiplication, I can drop these or add them as I want. So since it doesn't really matter whether the parentheses are there, all I have here are 7 threes. And according to the definition of exponents, that's equal to 3 to the 7th. So if you have two exponential expressions you're multiplying, you're just going to add their exponent with the same base. It does have to have the same base. You just have to add their exponents. If they have different bases, like 2 to the 5th times 3 to the 4th, the only way you can combine them is by evaluating the exponents first and then multiplying the numbers. So you'd actually have to calculate 2 to the 5th and 3 to the 4th and then multiply. But if they have the same base, you can shortcut it considerably by just adding the exponents. Similarly to the multiplication in number 1, in division you subtract the exponents. So if you have one exponent over another, 3 to the 5th over 3 to the 2, you just subtract the exponents. Now be careful if you have something like 5 to the 6th over 5 to the 2. That is going to be 5 to the 4th. A common error of my students is to try to reduce between the exponents and say, well, that's going to be 5 to the 3rd because I divide the exponents. Please don't do that. You will make your math instructor sad. The only reduction that goes on here is this. 5 to the 6th is equal to 5 times 5 times 5 times 5 times 5 times 5. 6 5s. And 5 to the 2 is equal to 5 times 5. Two of them reduce away, and that's why you end up with 5 to the 4th. You cannot reduce between exponents like that. Just subtract them, don't try and reduce them, and I'll be happy and you'll be happy. Moving on to Law 3. On Law 3, we have an exponential expression, a to the m, raised to another power. When you have an exponential expression raised to another power, you just multiply the exponents. That's fairly easy to see why as well, just by Law 1. Because let's take a simple example. 5 to the 2 to the 3. By definition, that means 3 5 squareds multiplied together. And by Law 1, we just add those. And we get 6. So, if you have an exponential expression raised to a power, it's just a multiplication. So here we see in their example, 3 squared to the 5th, you multiply the 2 times 5. Law 4 shows you that exponents distribute across a multiplication. Law 5 shows the same thing for a division. If you have a multiplication inside of parentheses, the exponent will distribute through. So you get 3 to the 2, b to the 2. And that will combine with the previous laws, So if you've got something that already has an exponent in there, like xy squared to the 3, remember it'll distribute to the x, but it'll also distribute to the y squared. You don't really have to put in this intermediate step. I'm going to for this time, but in the future I will probably just jump. X cubed, of course, is just x cubed. Y squared cubed, we just saw, is y to the 6th. And similarly for fractions. If I had 5 over x cubed to the 3rd, I would get 5 cubed over x to the 9th. One of the most common errors on these problems is forgetting to put the exponent on the number as well. I'm even occasionally guilty of that, so just be careful. Especially if you've got several pieces inside, people might put the 2 on the A and the B, but forget to put it on the 3. Don't forget to put it on the 3 as well. And we're nearly done here. These last two are almost barely worth mentioning. 6 and 7 just re-emphasize the idea of negative exponents. If you have a negative exponent on a fraction, you can just take the negative part in. It would distribute and you get a to the negative 1 and b to the negative 1. All that would do, though, is just flip the b to the top and then a to the bottom. So that's what they're showing here. They just took the negative in, the 3 flipped to the bottom, the 4 flipped to the top, but it's still a 2. And 7 is just another explanation, another example of the same thing. And I think we'll stop it here and start up the next video with some exercises dealing with exponents. I'll see you in the next lesson. It'll be P3 Part 2, and I think we'll probably end this section in 3 videos. Hope you enjoyed the lecture.